are going to have a very interesting episode today, Turning the Tide, Collaborative Innovations in Red Tide Mitigation. I couldn't even say it. Mitigation. So I have with me today Al Kennedy, research biologist, and Chris Cummings, social scientist with ERDC's Environmental Laboratory, otherwise known as EL. Good morning, gentlemen.
Good morning. Great to be here.
Good morning.
Good morning. Good morning. So we're going to start off with something very, very interesting. We're going to be finding out about both of you. So can you tell me about yourselves, your background, and your roles at ERDC?
Sure, I'll start. My name is Al Kennedy. I've got a fairly diverse background. I'd like to say it was all planned, but a lot of it just kind of happened. It was a winding path. I'm a research biologist with the ERDC Environmental Laboratory. Been working there since 2006. I have a bachelor's degree in environmental biology from Michigan State University and a master's degree from Virginia Tech in environmental toxicology. And then I worked at ERDC for a decade and a half and decided to go back to school through the long-term training program, which is an excellent opportunity through ERDC, and earned my PhD at Virginia Tech in polymer science and engineering. And you can see all these things are kind of diverse, and I figured out ways to integrate them into a project just to have multiple subject matter expertise just amongst myself, as well as being able to communicate with other groups for team building. I speak many languages now. I've been a PI for both civil and military projects during this time. The military projects span things from engineered nanomaterials, fate, mobility, effects in the environment, looked at things like munitions toxicity, new emerging contaminants like PFAS, and even implications of additive manufacturing, otherwise known as 3D printing. The civil work involves things like, just pursuing the Corps' mission of moving dredge material in our ports and harbors and doing physical, chemical, and toxicological evaluation of those types of materials, including research that spawns off of those types of routine assessments. And then more recently, I've been fairly heavily involved in ERDC's Aquatic Nuisance Species Research Program. Mm-hmm. The project we're going to talk about falls right along those lines, but it's actually funded externally.
Fantastic. Chris?
Yeah, it's great to be here with you. My good friends would say I have a wonderful face for radio, so nice to be on the airwaves with you this morning.
Great.
Like Al, like Dr. Kennedy there, I've had a bit of a long, winding road to get to where I am with the ERDC. My background, I'm actually a research social scientist, and all three of my degrees, bachelor's, master's, and PhD, are all in strategic health and risk communication. So a lot of my work deals with how we come to navigate risks in our society. And a lot of my research, academically and professionally, has been around emerging science and technology issues. So similar to Al, I've been more on the social side, studying things like emerging nanomaterials, synthetic biology, geoengineering, novel biotechnologies. I came to the ERDC just a few years ago. Previously, after finishing my PhD, I took a professorship at Nanyang Technological University in Singapore, where I was there for 6 years, studying and working on issues related to how we navigate our risky society. And I'm a behavioral theorist by training, and I wrote a theory called secondary risk theory that helps to predict and understand how people come to make judgments about issues where the cure of one particular thing may actually pose new novel risks, and how people come to make sense out of that risky landscape. And so I had, a half decade of studying things like vaccine hesitancy leading up towards publishing this theory, which I published at the start of 2020, right before the world went wacky with COVID. And it was at that time that I transitioned back to the United States. I left my job in Singapore in December of 2019. And once COVID kicked off, I got a phone call from colleagues who are in the ERDC who had written a book with Dr. Igor Linkov and Dr. Benjamin Trump, saying, "Hey, we hear you're back in the United States. Can you join us for 2 weeks on a COVID-19 risk task force that we're assembling? We can hire you for 2 weeks as a contractor while we all watch Tiger King as this thing blows over at home," right? And of course, 2 weeks turns into 2 months, turns into 2 years of me working as a contractor. And then I applied and and became a federal employee working within the ERDC EL. So now I do help assist folks like Dr. Linkov and Dr. Trump. I have the pleasure of serving as the deputy lead for a new center that came out of our COVID mission work called the Center for Engineering for Public Health and Human Factors, and that is situated within ERDC. So very happy to be here this morning to talk about this amazing project that Al's been leading, and we'll enjoy the conversation.
And I noticed your reaction when Chris said Singapore, since it's audio only. But yeah, Chris always has to kind of one-up me in terms of interesting story, right? So that blows me away. But it's so important to work with guys like...
winding road's a little bit longer.
But it's so important to work with guys like Chris on these types of projects, because one thing that a lot of scientists and engineers are so bad at is talking about the importance of their technical work in a clear, understandable way, and understanding people's reaction to it and how to best infuse it into the application stage when we try to scale something up.
Absolutely. And plus, what's so fun is doing these shows, it's fun to find out about each of you. And that's why it gets people more enthralled about what we're going to talk about, because they learn about you and learn about what you do. So this is the fun part. So, and then I also learned about something about both of you that I did not know and did not notate. You both have your PhDs. I did not have that written anywhere. So we're going to start off with this next question. Let's start by explaining what red tide is and why it poses such a significant challenge along Florida's coastlines.
Yeah, and I'll take the first crack at this one. And I say crack because I'm not a red tide expert. I got brought into this project for other reasons, like environmental toxicology and the material science. I talked about some of the Virginia Tech work. The folks that we're working with at NOAA and University of Delaware are truly the experts in these harmful algal blooms. But they're called harmful algal blooms, right? But what we're actually talking about is it's classified as more of a protist. It's not truly algae, but it's called algae because it kind of photosynthesizes to make its own energy, and it can also consume things from the environment. So it's called a heterotroph. So it's got all kinds of ways that it can consume food to help its growth. And that's why it's such a threat. It's actually a dinoflagellate called Carenia brevis. And it's just like a small organism that's, you could fit a bunch of them along the width of a human hair. And they've got little whippy things that help them move around called flagellum. And uncontrolled, these organisms can explode in terms of their population growth. So it goes from like almost nothing there to all of a sudden the waters in coastal Florida start warming. And then there's things that happen like nutrient runoff, like nitrogen, phosphorus from like agriculture, fertilizers, or upwelling from the sediment. And all these nutrients build up, giving these animals more things to feed on. And then all of a sudden they explode. And that's where the red tide comes from. There's so many of them. There's a pigment. The water actually turns red. It's them.
Okay.
They're microscopic, but they're so densely packed, it looks red. And the problems associated with this, there's problems to both human health and ecosystem health when we have these types of population explosions. Probably the most obvious thing is the aesthetics, right? How it looks. Florida, for example, is a well-known tourist state, right? Mm-hmm. A lot of economy for people coming down to visit. And if you're going to the beach, you don't want it to look red. It's kind of unappealing. And that really has...
Blue and green is the better colors.
Well, that's the freshwater side. Those blue-green algae, not so desirable either for beachgoers. But yeah, so it's red in this case. But the other problems are associated with a brevotoxin that these organisms can actually release. So it's a neurotoxin, and it also causes respiratory effects. It can actually, during wave action, come up out of the water, and anyone who's above the water or near the beach can actually inhale it and cause respiratory problems. The neurotoxin is in the water, and it can cause impacts to important threatened endangered mammals like manatee. It can cause fish kills. Obviously, if you're in the water and it gets in your mouth, that can be a lot worse than when it's not in your mouth. So there's a lot of issues. And it also accumulates in seafood like shellfish. So if people start eating shellfish, it stays in the shellfish, and then it can cause them, health problems afterwards. So it's something that people really want to get better control of because it causes a huge economic and health impact.
Absolutely. Okay. Chris, was Chris going to add any to that? Okay. So,
Yeah, the only thing that I would add there is beyond all of these immediate effects, you do end up with all these secondary and tertiary effects as well. Beach closures causing, massive drops in tourism. So this has been an issue that, of course, has a long history, especially in places like Southwest Florida, where, we see this not only just impacting the physical health, but also the societal financial well-being of local people who are in fish and game and tourism and things like that have taken a large hit due to the red tide blooms.
okay, so here we go. What is DinoSHIELD and how does it work to combat red tide?
Well, earlier I mentioned partnerships, and they're so important. And this technology was originally conceived at the University of Delaware through research, and then kind of continued it at NOAA. And the leads on those projects were, and I mentioned Latin before, but there's actually harder to pronounce names, like the lead of this project. We call her KDP, but Doctors Katie Pukshavinsky, Dr. Kathy Coyne, and later on Yangfei Wang are the PIs besides myself on this project.
Right.
And they did a lot of the research on basically a natural algicide that could combat the DinoSHIELDs that come out of a bacterium that occurs naturally in the marine environment. So we're kind of using something that's already there and concentrating it so that it can get to a level that can start impacting the DinoSHIELDs. And they found that this algal toxin released from this bacterium is specific to the dinoflagellates. So they haven't found, or we haven't found, any impacts to other like fish or organisms that are desirable to live in the water in our oceans. Mm-hmm. So that's really the hook here. It's a biological control, so we're not introducing a new chemical to the environment that targets the dinoflagellates that cause the red tide. And then additional research went into this to figure out, well, how are we going to deploy this in the field? How are we going to grow enough of the bacteria in a lab? Mm-hmm. And you can't just throw bacteria in the environment, right? So that's where DinoSHIELD came in. It's basically a polymer ball that's also bio-based. It's actually an extract from brown algae, so it's non-toxic, and it serves as a little cage to put the bacterium in, or the extracted algicide that come from the bacteria. Mm-hmm. And now you've got these little soft, squeezable polymer balls about the size of a BB that are kind of like Orbeez. If you've seen those before, mm-hmm. They're like squishy little BB-like things.
Right.
And you can put them in bags. And then they have a slow release of the algicide that we can actually control based on how we make it. So that's the technology and the real hook, where we're using biology to combat biology. That's
fantastic and fascinating too. Did Chris have any addition to that?
No, the tech specs are all Al.
All Al, okay. So how is this control technology made, and what is different about it, and what inspired it?
Well, I can maybe address what inspired it first. Okay. So these little hydrogel balls, the little gel balls, it's actually, the polymer is called alginate. These are things that's already been used in biomedical research for controlled drug delivery. So like, you take drugs, you consume them. It's already known that it's biocompatible, meaning the biopolymer itself isn't going to hurt people when they consume it. Mm-hmm. And then biomedical folks, researchers, can put the drug they want to deliver in it, and it slowly releases in the body. The innovation of this project is that this is the first time it's been used for an environmental application, so outside the human body to combat some sort of issue. And the innovation that ERDC added, I guess there were several, the production of them was very, very slow. You could make a couple of these little beads and do some research in the lab, mm-hmm. and the control of their size and shape wasn't so good. So we came up with a method to more mass produce them for field demonstration, to go beyond the lab, because that's always difficult, right? You can get something to work in the laboratory, but then you have to figure out how to scale it up so that you have enough of it. And there's all kinds of factors in the environment that aren't a factor in the lab that can make something
Right.
work better or worse, but oftentimes worse. It kind of confounds the application. So basically what we have is this kind of viscous material, almost like honey, though it's not as sticky. We can mix that material in with the algicide or the bacterium, and we've extruded it through tubes or a series of tubes, and we've added some 3D printed parts to it so that it's completely customizable. And then we can dramatically increase the production of these polymer beads. And then they're still kind of runny, right? So we use a polymer-based method to cross-link them. So if you think about like cooked spaghetti, that's what the polymer chains are like. They're these long chains that kind of wiggle around as you're
Right.
pushing them through a tube. And then when you dry out spaghetti, it solidifies, right?
Right.
And they don't move around anymore. So we drop them into this salt solution to cross-link it. So that's how the ball is formed and how it becomes a solid ball. It's still squishy, but otherwise it would just kind of run away like honey. And that serves as that cage that holds in the algae, or it holds in the bacterium rather, or the algicide extracted from the bacterium. There's two ways we can deploy this. And based on how we make it and some other things, material science factors we put into it, it can control how fast the algicide is released. You might want to treat something fairly quickly because
Right.
there's an active bloom, and you might want to have a slower release to kind of keep that bloom down. So that's sort of the idea of this technology and how we can control the release of the algicide rather than just throw it out there and it's there and it's gone.
Right. Right. How did the collaboration between ERDC, NOAA, the University of Delaware, and the Florida Sea Grant come about for this project?
Right. So that's actually a fairly easy question to answer, and an interesting one where Dr. Katie P., I'm going to transition to that now.
Okay.
Actually, she did her graduate research at University of Delaware, right? And then after she graduated, she got a job at the ERDC Environmental Laboratory. And she worked there for a number of years. That's where we met. And then a few years ago, she transitioned to NOAA to do research at that lab in North Carolina.
Okay.
So there's the ERDC NOAA connection and the
Right.
University of Delaware connection. And we're still working with a professor up there, which is Dr. Kathy Coyne, and a postdoc, Yangfei Wang, to do the technical research. And then, I mentioned earlier, scientists and engineers just need a lot of help to communicate what our work is doing and
Right.
what the broader implications are. So that's why we started working with Chris. And you mentioned Sea Grant. That's why we started working with Sea Grant. Florida Sea Grant has great connections to folks like resource managers, people who are actually interacting with the public. They understand the problem. So Sea Grant really helps us with our outreach. To better discuss things and have workshops and get input back
Right.
from the local community.
Plus, you can have radio shows where people can hear it and then see if they know anything they can do to help.
Oh, I'd never thought of that.
Right. Chris, did you have anything to add?
Not on that, no. It's
Okay.
been wonderful to work with these folks, though.
Partners are so important. So what were the key goals of the stakeholder workshops held in Florida, and how did they contribute to the DinoSHIELD project?
I think I'll take the first crack at this one, and Al can add more. A lot of the work that I do that tries to improve some of the inclusion of diverse stakeholders comes from a framework called the Responsible Research and Innovation Framework. And this isn't just a theoretical framework. It's really a practical approach to help ensure that innovations like DinoSHIELD are both scientifically effective and socially accepted. And so by including stakeholders and addressing their unique concerns, we can start to develop robust solutions to complex ecological challenges like red tide. So these stakeholder workshops were really for us to present the amazing novel work that has happened to develop DinoSHIELD, but to also take on more of a listening posture so that way we can help to include, these diverse sectors from government agencies, academic fields, people on the ground in the actual communities that will be likely end users of this product, so that way they can actively inform how DinoSHIELD will be refined and tested as they move towards future field trials. So really, part of it, the need and goals of the workshop were to build and maintain trust, where these workshops can provide a platform for stakeholders to learn about DinoSHIELD. And at least from increasing that familiarity, they can have more comfort in actually solidifying opinions about the uses of biological controls like this for combating red tide. And we saw that bear out. One of the other roles that I've had with this project was to do more formal assessment. So as a social scientist, I do things like interviews and surveys. And so we did a pre and post test survey at each of these workshops to judge if people were, one, getting out of the workshops what we hoped, so they actually learned more about DinoSHIELD, and then to see if their attitudes about biological controls changed. And we saw, obviously, they came in with very little to no knowledge about DinoSHIELD and left with a great deal of knowledge, and we were able to measure that. And we also saw that they were much more accepting after the workshops to consider using something like DinoSHIELD as an effective mitigation strategy. So building and maintaining that trust is paramount. And then also, the workshops really helped us to do things like identify and anticipate potential risks, such as concerns about the deployment systems that might actually impact marine life. One of the more interesting findings that we had from the workshops was that, by and large, our stakeholders were very positive about using DinoSHIELD, but they were more concerned about how we were going to deploy it in field trials and more concerned about things like the bags and ropes that might be used to solidify, dropping in these bags of the beads in certain locations, because when the hurricane comes, it's going to blow them off, and they were worried more about the ropes than they were about the biological control agent and algicide inside of the bags. So fascinating that we could learn that from them, and they've actually started looking at adapting the deployment strategy to use things like biodegradable bags and biodegradable rope or other deployment systems to make sure that they could be retrievable. Other things like just simple inclusion, making sure that we do have diverse representation, and then responsivity. The feedback that we get from these stakeholders can be used to change the course of how DinoSHIELD is enacted. And so all of those became the primary goals for these workshops.
Wow. Alva, do you have anything you'd like to add?
This is where I get to say Chris knows his stuff, and I have nothing to add about the objectives of the workshop.
Okay. Chris, apparently you know your stuff too. So, well, is it important to involve local stakeholders such as harmful algae bloom experts, HAB, and resource managers and extension professionals in these workshops? And why did you feel these connections were so critical?
When we're talking about something like a deployment of an actual technology, it has to be deployed in a real place with real people in real time. And so having those local insights and sensitivities of understanding what's actually happening in that location is paramount to successful deployment. So involving stakeholders like other harmful algal bloom experts, resource managers, and the like gives us direct access to their experience and lived experience working in the Gulf Coast. And so providing those region-specific insights are really critical for effective deployment. And again, that just emboldens and builds more trust. These folks who we got to meet with, listen to their concerns, talk through all of the issues that they might identify, will leave there knowing that the work is receptive to what their thoughts and needs are, as they are the ones who are truly fighting red tide day in, day out. And so we want to use that group as our kind of bellwether for understanding what kinds of things we need to consider. And so they brought up how a lot of them will have constituents that come to them for information. And so we got to talk with them about what kinds of information would they need to be able to actively discuss DinoSHIELD in a robust way with their audiences. And so being able to have that dialogue with them really helped to foster and maintain and build that trust that will last years as we try and tackle this problem together.
Anything to add, Al?
Yeah, I mean, I guess it's interesting seeing different ways of thinking when you go to these workshops, because, as a toxicologist, I'm thinking the main concerns are going to be, well, you're putting this technology out in the environment. What's going to be the impacts on like aquaculture, other fish that live in the environment? I'm thinking that there's going to be a lot of concerns, like, is it actually going to work? When you put it out in the field, and yeah, those are concerns. But there were other things that were brought up. Chris mentioned one, like the interaction with marine
Right.
mammals. There was more concern with just some of the materials that were deploying the technology in rather than the technology itself. And then there were other comments I never thought about either. Like when red tide happens, the people who are impacted with it they're so impacted that they just want to know something is being done.
Right.
So if something is deployed and they see like local officials making an attempt to make things better for them, that's sometimes a win.
Right,
So that
right.
that was interesting seeing those types of perspectives.
So, can you talk about the role transparency and collaboration played in building trust between the researchers and the stakeholders?
Sure. Yeah. I mean, and the first level answer here is a fairly simple one. No one would want a big surprise if they walked out into their local waterway and suddenly someone was conducting a field trial in their local waterway. It would feel like they've been disrespected or bamboozled in one way or another. So one of the main goals in increasing that transparency is to let people know what the plan is, so that way they can be part of the actual action plan. If we're going to be doing things in a particular community, we want that community to have some ownership over what's going to happen when we're doing things like these field trials that they'll be hopefully doing in coming years. And so transparency helps to build that trust not only in the actual community and understanding of what's going to happen, but these workshops also facilitated just much more robust understanding around the science and data and safety testing that has already gone into more than a decade or two of research into getting this far. And so that, I think, has certainly been important. These workshops also fostered a really good two-way exchange of knowledge where participants were able to provide direct feedback to the exact people developing the technology. And that's really rare. When you think about commercialization of a product, oftentimes you might have people in a focus group or something that, have some say, but it's very rare to have direct input into here's the type of safety testing we think you should do next. And we were able to get that feedback from these exact stakeholders. And there are plans to enact a lot of the types of things that we heard from those stakeholders. And that then allows us to invite better critical feedback that helps to push forward the project in a much more socially robust way.
What were some of the main research gaps and concerns identified during the workshops, and how did the team address them?
Yeah, so I've mentioned this before, but scaling up is a major concern both for us and the stakeholders in these workshops, because they know the complications involved in it and obviously the cost of scaling up, right? So we addressed that one by talking about how effective it is in the laboratory. We've already done a small mesocosm demonstration up in Delaware. We talked about how the objective of this technology isn't to treat the entire ocean, right? The idea of the technology is to target specific areas.
Areas, right.
It could be like a yacht club where people are going to have a lot more interactions. It could be backwater areas or channels or inlets, like around residential areas where there's docks. Mm-hmm. So we're talking about more confined spaces there. And we talked a little bit about, you probably don't want a number of PhD level researchers in the lab mass producing these materials. So we're already coming up with plans on technology transfer. Like, how do we transfer, after patenting the technology,
right,
this manufacturing process to private industry? Because they're the folks that are really good at figuring out how to mass produce something
right,
at a lower cost
right,
than the government can do. So the government's really there to take the risk out of producing something, doing the initial ground level research. So that's how we talked about that one. Interactions with the manatee, I think there was just basic review and better understanding of these bags and ropes and things that would be deployed in the environment. So some of the suggestions that were actually thrown out there is looking at other biodegradable materials. So if some of these bags get disconnected. We talked about how everything we have in our technology is a biopolymer, bio-based. So that will degrade. It's not going to last ever in the environment, but certain polymer mesh bags do have a lifetime in the environment. There's concerns with them breaking up and become microplastics or entraining, marine life and things like that. So one of the other research pushes we got from the workshop is let's find a biodegradable material that's going to last for the period we need it to. The intent is to put it out in the field and then retrieve it.
Right.
Right. But things happen, things get cut, it might float off somewhere. So that's sort of the attractiveness of looking at something that's biodegradable. There were some concerns about, non-target species effects. And those would be things that aren't the dinoflagellates, that aren't the red tide. Mm-hmm. So we talked a little bit more about the controlled release. The research we really put into it was to slow down how quickly the algal toxin comes out for prolonged, treatment of the red tide. There's also new permitting requirements that are requiring us to do additional laboratory-based non-target species testing. And again, that's my bread and butter besides the polymer stuff, is we run a live animal testing lab of all laboratory cultured animals,
right,
to figure out what levels of a contaminant might cause a concern. So we're really scaling up our efforts to run those types of bioassays on this DinoSHIELD technology to show folks who make decisions on the regulatory permits, we run your actual test method that you use to make decisions on something is safe in the water, and here are the results, kind of increasing those types of comfort levels. So those are just some of the examples of some of the things that came up and how we decided to discuss it. And we're going to be disseminating all those things, in later publications as well. So other folks that are developing a technology, not necessarily similar to DinoSHIELD, but following a similar path, can kind of follow our framework of how to communicate the pros, cons, strengths, benefits.
Right.
And again, the amount released is fairly small. The intent is to get ahead of a red tide, mm-hmm. and the algicide is specific to the dinoflagellates' growth. So it doesn't necessarily immediately kill them, but it keeps them from like that exponential growth. You've got a few of them, and then it just stops that population in its tracks.
Okay. Chris, do you have anything to add?
Yeah, besides all of these research gaps that Alf talked about, we also were able to identify some of the more process-oriented or logistics kinds of concerns as we start moving towards field trials. One of the main reasons why we went in person to Southwest Florida was to make contact with the people who would be around for these things like the field trials. And those folks were able to identify a lot of the kinds of potential issues and logistical concerns for upcoming field trials, some of them going as far as being able to say, I'll be your champion and help you as you move towards these field trials. So being able to have that input from local stakeholders was certainly something that we appreciated as a significant outcome from those workshops.
So tell us about the upcoming field study of DinoSHIELD and how will it contribute to the fight against red tide, and what do you hope to learn from it?
Right. So we've actually intended to already have done a field study, but we were waiting for the right red tide to occur in Florida. And we're still
What
kind
is
of
the
waiting.
right red tide?
Yeah. So there are some sites selected, kind of these like smaller backwater areas, or like a constricted channel, that we've been targeting, and a red tide hasn't occurred there. Like working with local officials to get approval to do that testing there, like whether there's manatee, present there or not, really controls on if we can do it or how we could do it. For example, if we're going to do a larger scale field trial and we're not treating the entire ocean, we want to catch the red tide as it's, building up, not when it's built up. And NOAA and others have technologies for the monitoring to kind of catch that before it happens, is the idea. But if there's manatee present, we have to contain our demonstrated area in sort of a research plot. And the Corps of Engineers is very good at doing things like silt curtains to control like spread of suspended sediment particles during, a dredging operation, so that those particles don't travel too far and cause like aesthetic issues in terms of darkening the water.
Right.
So silt curtains would be perfect for containing like these test plots. But if there's manatee present, that's a physical barrier that a lot of the folks would have concerns with. How are the manatee going to get through that? Are you trapping some inside? Of course, we'd be looking for that. But in those cases, we'd probably have to deploy something different, like a bubble curtain technology, which basically is a lot of air bubbles, coming up in some sort of a shape of our control plot. And the manatee could obviously swim through bubbles.
Right.
Might actually play in it. I'm not entirely sure. So that's a lot of the work that needs to be done to determine what and when we can do. I mentioned the new regulatory requirements.
Right.
And some additional things we're having to consider is the regulations are a little bit different based on if it's just the algal toxin that's put into the DinoSHIELD bead, or if we've contained the bacteria. It kind of transitions from one organization to another that's doing the regulatory decisions on it. And I'm purposely not mentioning those agencies, but I know what they are. So there's a lot of considerations there where we're writing for the right conditions. We're also working on things like determining like the success metrics, so we can determine iterative improvements. So as we're waiting for these right conditions to occur, we're expanding our mesocosm. So we have different mesocosm labs like at NOAA or ERDC, or there's a research lab at Moat where we had one of our workshops down there in Florida. It's a user facility. So we're going to be doing testing in this next year to show that this material works as we get ready for this red tide to actually occur.
Okay. So how will the insights gained from these workshops shape the future of red tide mitigation strategies and the ongoing development of DinoSHIELD?
Yeah, I think, if we really want to maintain this kind of responsible research and innovation posture, it's important that we continue to engage stakeholders as we already have been, so that way we can broaden some of the views that we get from diverse stakeholders who will be impacted by deployment. So being able to continue to have dialogue with them, have listening sessions where we're understanding their thoughts and views as the project continues, to make sure that we're responsive to these communities and understand that they're in a way a co-producer of this technology along with us. So that way we're making sure that the developments of DinoSHIELD are done with deference towards public will, towards making sure that at the end of the day, we do no harm and we actually do something that aligns with what we want to do, which is help improve society and help mitigate red tide. So making sure that we don't accidentally cause secondary effects or new risks from things like these deployments.
And we are wrapping up with the last question. And as we do that, what's the key takeaway you'd like our listeners to have from this conversation?
All right, so I might add one additional thing with working with the stakeholders.
Oh, I'm sorry.
And I mean, that is that they help us realize that, DinoSHIELD is just but one tool. There's a lot of different strategies to control a red tide. And they help us determine, like, this is a great place where this could work versus you probably don't want to try it over here.
Right.
So it's that kind of communication that's really going to guide the success of demonstration to get that public trust. So getting them engaged early on prior to the demonstration.
Super important.
So critical.
Right.
But in terms of what we want people to take home is again, from my perspective as a toxicologist, with the concern of not impacting other organisms that live in the environment, and a lot of the other options that are out there for, controlling some sort of algal bloom have a chemical involved. So some have copper in them. There's a lot of commercial products that are permitted at a level, in my mind, that's above copper levels that kill animals in my laboratory. It creates legacy contamination. There's other peroxide-based things that are probably much better, because peroxide is something that is more short-lived in the environment. It actually degrades away but there's still going to be that initial effect on other organisms that may be adjacent in the area. So I think the take home is like biological controls are really an exciting way to go, because we're, again, harnessing some sort of natural thing to combat the nuisance natural thing that started occurring, that honestly started occurring because of human interactions with fertilizers and other things like that. And R&D really is the way to go to get some sort of crazy idea like this DinoSHIELD. Let's put this thing in these polymer beads and it's going to work, to get that crazy idea to the next generation go-to technology, through demonstration. And that process does take years. So, the public has to be patient, because we have to work out so many different things. How does it work? In what situations does it work? What's the mechanism that it works? What are things from the environment that could make it not work? That's how all these kind of technologies eventually develop, we consider as our go-to technologies. And, we talked about partnerships a lot. And I think, ERDC and the University of Delaware and the NOAA researchers, have a good grasp of the technical aspects of the technology, the material science factors, the biology of the red tide, the dinoflagellates that make the red tide, how we need to do our experiments, how we need to generate the type of data that's going to be convincing that this technology is going to be the next best thing. But again, that communication piece, working with Sea Grant to actually bring in people who know the area, right? We're way up here. We're not in Florida. They know the area. They help guide us. Getting their buy-in and engagement was so critical. That's the power of public-private partnerships. And then bringing in social science aspects and how to basically, we talked about the name of the technology and what people were going to understand from it. Like, is that obvious what it's going to actually do? Or is it just going to confuse everyone as the next newfangled thing? Like, oh, the eggheads are at it again.
Chris?
Yeah, I mean, we were able to host workshops with, constituent stakeholders who they themselves have their own public communities to which they serve. And I think it was really fascinating as the workshops continued to learn that many of the things that folks were concerned with were not the science, and that people didn't care so much for the science. What they cared about was risk, right? At the end of the day, they were worried about, what is the public going to think of this technology? Can you demonstrate its safety? And can you say that it works? And so when we get to that level of distinction, it's important as a key takeaway, I think, for the ERDC, is to know that when we're talking about how the public comes to assess an intervention, a technology, a building plan, they're not going to care as much about the science. They're going to care about, is it safe? And so when it comes to that, we need to make sure that we build and maintain trust and improve our transparency around discussions around risk, so that way we can, at the end of the day, know that we're making good decisions that are going to make people feel and understand that the interventions that we're doing are with their best interest in mind.